everybody, let's talk about solution stoichiometry. We've already learned about stoichiometry. All we're going to do is add a little more flexibility to our process. So when we talked about stoichiometry before, we would start with grams of a material, use the molar mass to convert to moles, and then once we had molar mass, we would use that balanced chemical equation and the coefficients in that balanced chemical equation to find the mole ratio, and that would allow us to convert from the moles of the first chemical that we were given in the question to the moles of our target. And then once we had the moles of the target, we would again go back to the periodic table and use the molar mass to calculate grams. That works great if your material is a solid. But when you have something that is an aqueous solution, it's pretty hard to measure the grams of the chemical because it's mixed in with all of the water. So we're going to use our molarity equation to allow us to convert from liters of a solution to moles of that solution. So you remember your molarity equation is the molarity is moles divided by liters. We'll use that instead to get to moles. The second step stays the same. Use that balanced chemical equation and those coefficients to convert to moles of your target chemical. From there, we'll use our molarity equation again, and that will allow us to figure out the liters of a solution that we would need to add, or sometimes we'll use it to calculate the concentration of that second solution. So we've taken what you already know, and we've added more. Let's take a look at two problems. The first one, what volume of 0.855 molar H2SO4, that's sulfuric acid, as an aqueous solution, is needed to fully react with 15 milliliters of 0.0344 molar sodium hydroxide. As with so many of our stoichiometry problems, we need to know where to start. In this case, the chemical that we will be starting with is the one we know both a concentration and a volume for. So in this case, that is 15 milliliters of 0.344 molar sodium hydroxide. That's our starting point. We are going to take that and use our molarity equation to convert to moles. I do want to point out that the question gave us milliliters. When you use the molarity equation, convert it to liters first. So that 15 milliliters, that's 0.01500 liters. So I have 0.00516 moles of sodium hydroxide. From here, I can now convert to moles of H2SO4 of our target compound. I carried out this conversion using both proportions on the left and dimensional analysis on the right with that mole ratio. Pick your favorite, get there. So now we have moles of sodium hydroxide. Our last step is to determine the volume of the sulfuric acid that's needed. Because we're still talking about a solution, we're back to our molarity equation. So I know in this case that the molarity is 0.0855 molar. We know the moles. So when I rearrange this equation and solve for x, I find that I get 0.0302 liters. This is 30.2 milliliters. If the question asks for milliliters, make sure you convert it. Otherwise, you can give me either liters or milliliters. Before I leave this, quick recap. Molarity equation, coefficients for the mole ratio, molarity equation. That's what we're doing for this. Second and final question, just a little bit different. Now I've got 45.3 milliliters of a 0.108 molar HCl solution, and I am trying to react this with a 25 milliliter solution of sodium hydroxide. The question now is if those are the volumes necessary to get a complete reaction, what's the concentration of the sodium hydroxide that was being used? So again, we're going to go molarity equation, mole ratio, molarity equation. We will start with the chemical that we know both a concentration and a volume for. In this case, that is the HCl. Once I have my moles of HCl, I'm going to use the coefficients to convert to moles of NaOH. It's a 1-to-1 ratio, so the moles turn out to be the same. The last step is to find the concentration of the sodium hydroxide. At this point, you know moles, and if you look back to the question, we know the volume of that solution. So we'll again use our molarity equation, but this time we're going to solve for the molarity. So I'll put my moles of sodium hydroxide in the numerator, and I will put the volume of the sodium hydroxide in liters in the denominator, and I find that my concentration then is 0.0196 molar for my sodium hydroxide. The last that I'm going to leave you with on this one, guys, is actually sig figs. If you look at the starting question, every number either had 3 or 4 significant figures. All I'm doing is multiplying and dividing, so my final answer should have the same number of significant figures as my measurement with the least number of sig figs. That in this case is 3. Do make sure along the way that each of the numbers you stop to after each step, you have at least 3 significant figures there so that you don't lose information just by doing the math and rounding prematurely. We will work on this in class, give you a chance to practice and ask me questions. Make sure you're making note of what makes sense and what doesn't.